All right, hey everyone. So in this lesson, we are going to talk about I can identify linear and non-linear functions. So we are going to wrap up chapter 6. This will be the last notes of this unit, and we will wrap up our test. I believe it will be on Friday. So just FYI about that. If you want to start studying, looking over your notes, looking over your homework, your quizzes, I would encourage you to do so. So this last lesson is talking about what is a linear and nonlinear function. The graph of a linear function shows a constant rate of change. Okay, a nonlinear functions, on the other hand, does not have a constant rate of change. So its graph is not a line. So all you have to really know is a nonlinear function is not a straight line. That's pretty much it. Okay, well, so from a table, how can I figure out a linear, nonlinear function, right? So does a table represent a linear, nonlinear function? So all you have to do is identify patterns, right? So here, notice I'm going up by plus 3, plus 3, plus 3, right? Notice how here I'm going minus 8, minus 8, minus 8, right? So you're looking at your rates of change. 3, 3, 3, negative 8, negative 8, oops, negative 8. Notice how they're the same, right? And, whoops, what is going on here? In my x's, I'm going up by the same amount. My y's, I'm going down by the same amount. So this is a linear function. Even though they're going up and down by different values, that's okay as long as they follow a pattern. And explain, you could write constant rate of change. So if you really want to abbreviate rate of change, you could really just write constant ROC, R-O-C. If you write constant ROC, I would assume that means rate of change. So you can write this as constant rate of change. Okay, moving on into example B, let's figure out the same way. I'm going plus 2, plus 2, plus 2. Here I'm going plus 9. Here I'm going plus 22. Here looks like plus 35. Notice how these are the same. They're different. My x's are the same. But my y's, I'm going by different increments. So because my y's are all different, this is a non-linear function. They have to go up by the same amount all throughout. Why? So if you want to explain, not a constant ROC. Okay. All right. Letter C. Is this a linear or non-linear function? Well, is this a straight line? Is all you have to ask yourself. If it's not a straight line, it's a non-linear function. Notice how this is not a straight line. So this is why? Because it's not a straight line. So therefore, it is not a function. It is a nonlinear function, excuse me. But letter D, this is a straight line, right? It's right here. This is a straight line, so it is a linear function. Why? Because it is a straight line. Right, so for tables, you're going to look for constant rate of change, right? You're going to see if they have the same pattern over and over again. For graphs, you're looking for, is it a perfectly straight line? It could be like this, right? It could go like this. It could go like this, right? But it has to be a perfectly straight line throughout the entire thing. Okay, so that's how you can tell if it's a linear or nonlinear function. So why don't we do 1, 2, 3 on your own? If I ever went too quickly at any point in this video, remember, feel free to pause it and you can restart it at your convenience. All right, moving on, next example. So we talked about, can you identify if it's a linear or nonlinear from a table and from a graph? Now what about for an equation? Yes, so here's how you do it. Just looking for an equation. All you have to do is look for your slope and your y-intercept. If you can identify your slope and your y-intercept, then it's a linear function. But if you can't, then not a linear, I should say linear function, then it's not going to be a linear function. Okay, so for example, in this one, can you look for a slope? Some of you may be like, no, there isn't a slope, but there actually is, right? This is a horizontal line, right? Because it's a y equals a number, so this has a slope of 0. My y-intercept is 4.7, so this is going to be a linear function. Okay, remember, if you have a y equals a number, that means it's a horizontal line, which means it's a slope of 0, which means the y equals a number, right? That's what HOI stands for. Next one, y equals pi times x. Some of you may be like, I've never seen pi, it's a little different, but it's okay. The slope is always a number in front of my x. So my slope is pi. That's my slope. What's my y-intercept? I'm not given a y-intercept. So it's just plus 0. So my y-intercept is 0. So if you are able to identify, right, your slope and y-intercept, then it's a linear function. That's how you can tell if it's a linear or non-linear function. So you kind of have to look for these functions for you to solve them. Y equals 4 over x. So this is a little peculiar because you can't have x in the denominator. Right, if it is a non-linear function. You also can't have like, if you have anything like x squared, this is also non-linear. Right, if you have like square root of x, this is also non-linear. Right, so you can't have like exponents. You can't have x to be in your denominator. Those are non-linear functions. All right, next one, let's take a look. So I see parentheses. Let's simplify this a little bit first. All right, so let's distribute. Get y is equal to 4x minus 4. Can I find my slope and my y-intercept? Well, yeah. My slope is 4. Y-intercept is negative 4. So is this a linear function or non-linear? This is a linear function. Okay? So why don't we try the next 3 on your own? Remember, if you have an exponent, it is automatically a nonlinear function. Okay, so I'll only try these next 3. All right, moving on. Example number 3. Account A earns simple interest. Account B earns compound interest. The table shows the balance for 5 years. Graph the data and compare the graphs. Okay, so let's graph it. I'll do this in this color. I'll do this in this color. So let me graph it first. So let's do years. I'll go 0. Remember, because it's over 5 years. So maybe I'll go every other 1, 2, 3, 4, and 5. And then maybe, so I'll do a little break in my graph, right? So that way I can start at 100. And then I'll just go up by tens. $70, $180, I think that should be okay. So now let me graph my account A balance. So it looks like account A at 0, it's at 100, at 1 it's 110, 2 it's 120, 3, oh wait, hold up. I have to be careful because it's like here. There we go. Perfect. So this is my account A. Okay, let me label it here to account A. Okay, now let's do my account B. So account B also starts at 0, 100, but then it's also 1, it's at 110. But at 2, it's like at 121, so it's like right here. So it's like slightly getting larger and larger, right? And then 161. So that's my account. It looks like it's going like this. So this is my account B. Oh, I almost forgot to label my other axes. So this should be account balance in dollars. There we go. So there is my graph. Okay, but that's not all I have to do. It says to compare the graphs. So using the terms we talked about earlier today, which one has a constant rate of change and which one doesn't? Well, it looks like account A has a constant rate of change. And account B is a non-linear, right? Because it's not linear. Is non-linear, excuse me. Because it doesn't have a constant rate of change. So that's the difference between the two. This is, I would even include that this is a linear function. Why? Because it has a constant rate of change. Account B is a non-linear function because it doesn't have a constant rate of change. All right, so today we learned to tell if it's a linear or non-linear function from a table. We learn how to tell it from a graph. And we learn how to tell it just by looking at an equation. So hopefully today's lesson is not too difficult. This is all their homework for today. You don't have any big ideas math. You don't have any worksheets to do. This is it for today. So make sure you take a picture and upload your notes onto Schoology, and that will be it. If you have any questions on the notes, we'll go over those tomorrow, and we'll get going with that. Okay? Have a wonderful day, everyone. Bye, guys.